Printed circuit board backplane PCBs are an essential component of many electrical systems, providing a convenient and efficient way to connect multiple printed circuit boards. We'll explore the basics of backplane PCBs and discuss the process of fabricating them. Backplane PCBs vary in terms of types, construction materials, and the key steps in the fabrication process. After understanding all essentials, you can create a reliable, high-quality backplane printed circuit board that meets your needs. What is a backplane PCB? A backplane PCB, also known as a printed circuit board, is an interconnecting circuit board that helps support and provide electrical connections for multiple electronic components. The backplane PC board provides a platform for connecting the individual PCBs that make up a larger electronic system. You can find the backplane PCBs in computers, servers, network switches, and routers. The construction of backplane PCBs involves several layers of copper foil laminated together with an insulating material, such as glass-reinforced epoxy or polyamide. This combination of materials allows the backplane to be very durable and reliable. The copper traces that make up the interconnections are placed in specific patterns to create a flexible platform that can support various types of components. Engineers use a backplane PCB to mount other types of PCBs, such as memory boards, processor boards, graphics cards, and storage devices. It also serves as a high-speed data bus between these components, providing faster communication and data transmission. The various types of backplane PCBs. Backplane PCBs come in a variety of shapes and sizes to meet the requirements of any design. These include double-sided, multilayer, surface mount, and rigid flex backplanes. Each of these types offers distinct advantages and disadvantages, depending on the application. Double-sided backplane. This type of backplane has two layers of PCB material being connected by an array of holes drilled through the board. The application of this type of board is popular for low-cost, high-volume products such as consumer electronics. Multilayer backplane. This type of backplane has multiple layers of printed circuit board material being connected by various types of wiring. You will see its application in complex designs where routing or high density is essential. Surface mount backplane. This type of backplane consists of one or more printed circuit boards with direct mounting onto the outside of another board. This type of board is suitable for high-speed applications, such as communication systems or computer networks. Rigid flex backplane. This type of backplane consists of two different printed circuit board materials. One layer is rigid and the other is flexible, allowing for greater flexibility in design. The board is ideal for applications with a large number of connections or tight spaces. By understanding the different types of backplane PCBs, designers can choose the right type for their application and ensure that their product has the best performance possible. Backplane PCB fabrication. The fabrication of backplane PCBs involves a subtractive process, such as the removal of unwanted material from a starting substrate to create the desired traces and connections on the board. The most common method of fabrication is a chemical etching process, where manufacturers bond the copper foil onto the substrate, exposing it to a photoresist to create a pattern. The resist protects the copper during an acid etching step that removes the unwanted copper, leaving only the desired traces and connections. You can do it either manually or with an automated machine. The complexity of the design and the number of layers will determine the board layout. The design is usually laid out in multiple layers, with each layer representing a different circuit or electrical signal. All the layers are then bonded together, creating the complete backplane PCB. The bonding of the layers involves either a chemical or thermal process, depending on the application. After bonding the layers together, you may need to attach additional components to the board. This can include mounting holes for screws, heat sinks for components, and connectors for external devices. Then comes the typical process of components soldering onto the board, while keeping some in place with other methods such as rivets or adhesives. In the end, you have to test it to make sure it works correctly. This includes electrical tests such as continuity tests and power tests to ensure that all the connections are working correctly. After thorough testing, the board is ready to use in its intended application. The advantages of using a backplane PCB. Backplane PCBs offer many advantages over traditional printed circuit boards. They provide greater flexibility in terms of design and layout, as well as the ability to support larger numbers of components. This makes them ideal for high-density applications such as telecommunications, medical, industrial automation, and computing. Using backplane PCBs also offers several other benefits. You can use them to reduce wiring complexity and cost since they allow for fewer wires in an interconnected system. Moreover, they make it easier to route signals and power within a device, allowing for more efficient communication between components. Besides, they help have the simultaneous operation of multiple cards or modules, which is beneficial in applications that require multiple functions. Moreover, backplane PCB can also help reduce the size and weight of the final product. This is especially beneficial in applications that require a small form factor, such as portable electronics or embedded systems. Moreover, you can improve the overall reliability of the system due to the added strength of the backplane substrate. The disadvantages of using a backplane PCB. The main disadvantage of using a backplane PCB is its limited flexibility. Since all of the components are directly connected to the backplane, it can be difficult to modify or add new components to the board. This makes them less suitable for applications that require frequent changes or upgrades. Besides, they are more complex and costly to manufacture than other types of PCBs. Another downside is that they take up a lot of space. Since they involve multiple layers, they require more physical area than simpler boards. This makes them less suitable for applications where size is an important factor. Besides, the wiring and component placement on a backplane PCB is quite challenging, since there are several connections to consider. Moreover, backplane PCBs can also suffer from signal interference. This occurs when the signals from one component interfere with those from another component, leading to system errors or data corruption. This is especially true in the case of adjacent components with poor shielding. Development trend of backplane. As technology advances, the need for higher performance and better reliability of backplane PCBs is on the rise. As a result, manufacturers are continuously developing new designs, materials, and components for backplane PCBs to ensure that they can keep up with the changing needs of the industry. The main trends in the development of backplane PCBs include miniaturization, increased functionality, improved signal integrity, and increased thermal efficiency. Miniaturization. One of the main trends in the development of backplane PCBs is miniaturization. As more and more electronics are packed into smaller and smaller spaces, backplane PCBs should keep up with the trend. By reducing the size of the components used in the backplane, engineers can reduce the board area, allowing more components to fit into a smaller space. Increased functionality. As devices become increasingly complex, backplane PCBs must also provide more functionalities. By increasing the number of pins and features, engineers can provide more features in a single device. This helps engineers to design and develop more sophisticated products that can meet the needs of the market. Improved signal integrity. To ensure reliable signal transmission, engineers must ensure that their backplane PCBs have good signal integrity. This involves optimizing the board layout, as well as using proper signal routing techniques. By improving signal integrity, engineers can reduce noise and the risk of data loss or interference from other signals. Increased thermal efficiency. Heat management is essential for any electronic device, especially those containing multiple components. To ensure that the system is not facing high heat, backplane PCBs should be designed with thermal management in mind. By optimizing board layout and component placement, engineers can ensure a quick and effective dissipation of heat. These are just some of the trends that are impacting backplane PCB design and development today. By incorporating these trends into their designs, engineers can create products to meet the ever-changing needs of the industry. Final thoughts. A backplane PCB, also known as a printed circuit board, is an interconnecting circuit board that helps support and provide electrical connections for multiple electronic components. The backplane PCB provides a platform for connecting the individual PCBs that make up a larger electronic system. You can find the backplane PCBs in computers, servers, network switches, and routers. Engineers use a backplane PCB to mount other types of PCBs, such as memory boards, processor boards, graphics cards, and storage devices. It also serves as a high-speed data bus between these components, providing faster communication and data transmission. Certain development trends can help engineers create products to meet the ever-changing needs of the industry. Would like to know more about the backplane PCBs or prototype PCB manufacturer? Email us at sales@nconline.com. That's sales@nconline.com. That's sales.